Uh, no, Veera, I don't think so.
I'm audible now?
And yes, Veera.
Okay, actually Bluetooth is connected, so that's what headset is not working. Anyway, let me share my screen quickly. So Docker file. So what is Docker file here? Docker file is a text file to execute instructions one by one. So Docker file contains number of instructions to execute the entire process here. Okay, let's go to understand the process now. Yeah. Okay, so Docker file is a simple text file that consists of instructions to build a Docker image. So for example, guys, if developers write a one application, you need to Dockerize that application. How to Dockerize the application? You need to build that application and create a image that is custom image. So how to write a Docker file instructions? By using these many instructions. Okay, the first instruction is from. So the first instruction is from. From is nothing but from instructions will help to pull a base image. So for example, if I want to deploy a Python application, I need a OS, right? So that OS will take from Docker Hub. Okay. And from instructions will help to pull a image, the required image from Docker Hub. And next. So run instruction is execute commands, local executable commands. Let's go here. Okay, run executable commands. For example, so inside Docker environment, so while creating a Docker build process, if you want to create any directory, if you want to install any instructions, M instructions, apt instructions. For example, this is base image is Ubuntu base image. So in Ubuntu base image, you are taking Ubuntu base image. If you want to deploy a Python code, if you want to run a Python code, I need a Python, right? So Python install, we are using run instruction. Directory create, we are using run instruction. Any installations in local, we are using any installation inside your environment, so we are using run instruction. So you will get a clarity if you do one task. And next, we'll discuss later CMD and the work directory. So work directory is to set a directory is nothing but cd command to set a working directory. Sir, hello, Ania, అని నేను ఒక హాఫ్ అన్ అవర్లో చేయనా? Okay, so work directory to set a work directory. So for example, inside Docker environment, if you are creating a multiple directories, which directory this entire files has to be store, has to be copy. That is called work directory. Okay, not mkdir. Work directory means inside if any folder is there, that folder is going to set like a cd command. Cd go inside like that. Next is copy. So this is copy instruction completely to copy your source code into the Docker environment. Copy any files. So we are using copy instructions. So your source code is there in the local. We need to move into the Docker environment. So files from local to the container. We are using copy command. So add instruction also looks like a copy instruction, but add is nothing but here copy we can copy directly from the same environment, but add command to copy the files, load the files, little advanced add command we can add a URL also. So what is the URL here? For example, your files will be there in any Git or anywhere. So we can call the URL by using add command. So to copy command, it will just process the files from the same environment like a same EC2 instance. But your files there in the different any like a Git or any S3 something different area. So we can call by using add instruction. Add is like a copy, but little advanced add will support some URLs. Okay. And expose is nothing but where exactly this application is running, which port this application is running exactly. That is expose. env is environmental variable. Okay, these are the instructions we are going to follow to execute any Docker file. So let's understand one process. You will get a clarity now. So let's go to the EC2 instance now. So this is my Docker Python Flask project, guys, cloned from my GitHub repository. So the first step is what? My end app.py is there, requirement.txt is there. So first step is what? This, if you want to execute this code inside EC2 instance, if I want to execute this app.py requirement.txt, I need a one server. That's what I have created, one EC2 server. Clone the GitHub URL, clone the GitHub repository, and install a Python, install dependency, execute the code. These are the steps. Okay, let's understand. So my end Python code is there. To execute this Python code, I need a one server. So server I'm creating EC2 instance. Whenever you create instance, we will get OS plus hardware so that we can easily deploy your Python code. But to deploy Python code, first we need to install dependencies, right? So connect instance, install Python. Next, install dependencies. And after that is what? Execute Python code. These are the steps. So install Python, we will use install python -y something command. Install dependencies, what? pip3 install -r requirement.txt. Manual process, whatever process we follow yesterday. Okay, and execute the Python code. These steps we follow yesterday to execute Python code into EC2 instance. This is virtualization. So I need to containerization. This process I need to containerization. Same process, containerization means I need a OS. So I'm taking directly base OS, Ubuntu OS. Ubuntu base OS. After that, install Python. I'm not going to deploy my application. I'm not going to execute my application directly into the EC2 instance. I'm executing my application into inside the Docker environment. Install Python and Same install dependencies. Install dependencies, same process. Pip install requirement.txt. And after that, execute the code. Execute the code means what is the command? Python 3 give app.py. So let me add instruction of Docker file here. So Ubuntu OS required, right? We need to use from Ubuntu OS. Next, install Python, right? Python has to install, right? So we need to give run instruction to install anything. And next, dependencies also install, right? We need to give again run instruction. And see here we need to understand one thing. Install Python. After that, we need to execute dependencies. Pip install requirement.txt, right? So it will execute the your local requirement.txt file. That's what we need to do. Copy source code into your actual environment. If you give copy means copy the entire code into this environment location. Once code is there, run the dependencies pip install requirement.txt. So code is there, right? That's what pip install requirement.txt will work. After that, execute Python 3. So executable commands we need to run inside cmd instruction. So if you can see in my Docker file, cmd entry point, I skipped before, now I'm explaining. Cmd is not cmd or entry point. These are the instructions to execute inside the container. So whenever run the container, immediately the CMD entry point will be executable, whatever command you have given inside the CMD. So my and CMD instruction is what? So inside local executable inside container means Python code I need to execute inside container so that container will be created, application will be accessed inside from the container. So in this case, I need to give the inside local container inside executable command is CMD, or you can give entry point also. We'll discuss later what is entry point and CMD. Meanwhile, just understand here Python CMD Python 3 app.py. Okay, so let's understand now. So here copy we can give any directory also here. If you give directory, so inside environment app directory will be created. Inside app directory, your entire code will be moved here. And after that, install dependencies and execute the Python 3. This is the process will work in Docker file. So let's understand now. Okay. VA Docker file. So we need to execute the, let's understand now, we'll explain later. So here we need to understand one thing. So we need to create a Docker file where your repository is exist. So my repository exists here only, right? So here only you need to create a Docker file. Okay. So this Docker file execute from here only. So Docker file is there in the EC2 instance directory only, but here by taking this instruction, one environment will be created by copying the code from here. One environment will be created. In this environment, we are installing the dependencies. In this environment, we are executing the Python application that is called container environment. So first, we need to build a Docker file. So how to build a Docker file? So Docker file name always should be there, capital D and Docker file. Docker file always we can create in this with this name only. Okay, let's understand Docker build. Command is to how to execute the Docker file. Docker build -t. Give the tag name of your image name. You can give anything. I'm giving simply Python image. Give dot. Dot means current directory. So I'm saying to my Docker build -t So execute the Docker file. Docker file is there in the current directory, and give after build, give a name of my image is Python. T means tag. So for example, if a Docker file is not there here, if you give dot command, it will not execute. Docker file is not found, error will get. Dot indicates same current directory Docker file is there, execute it. No need to mention Docker file name here. The reason this is default Docker file name. Okay, if you give different Docker file name, you have to give here -f again. Sorry, not here. -f here, give the Docker file name, custom Docker file name, if you can give. If you follow the default Docker file name, no need to mention Docker file name, just mention where exactly the Docker file is located. My and Docker file located in same directory, so dot. Always Docker file should be created in the same repository. So this is my Python Docker Python repository, right? Inside only you should create a Docker file where exactly your code is located. My code is located here. That's what I have created Docker file here, and also dependencies also here. So let's understand now. Let me build this process. After that, we can discuss one by one each command. So first step is taking Docker image. 2 by 5 is next installing the Python. So Python is installing in separate environment, not in your EC2 instance. Understand here. This separate environment is to build a image. This separate environment is to run a application. Build a image process with the help of Docker file we can write, and also we can run a container with the help of CMD instruction. Everything you will get clarity. Just please be patient for 5 to 10 minutes. Done. So Docker command is Docker images. Yeah, Python image is ready my end. Okay, and let me delete other image. Docker ps. Okay, let me delete this first. Docker rm container id. It is a running state. Docker rmi mysql -m. Deleted. Now Docker images my end only one image. See now, first understand this image contains source code. This image contains OS. This image contains dependencies of Python code like pip, whatever install Flask. This image contains CMD instruction. Okay, let's understand now here. So the first from instruction is we need some operating system. I'm taking Ubuntu 20.04. This is official popular one. Okay, and next is what? We'll discuss later what is ENV now. And next is what? We need to install Python. We need to install Python MyN. So this is Ubuntu, right? So if this is Red Hat or Linux is or CentOS instances, we need to run M commands. But this is Ubuntu, right? So Ubuntu, the package manager is apt, not M. So apt get update, apt get install, apt get delete, like this we need to use. So apt get update means update the operating system. apt get install -y Python 3.9 and Python 3 pip means installing pip, installing Python also. Okay. apt get clean means it will be clean unnecessary files. rm-rf var lib abt lists. So I'm removing this list inside. The reason, whenever install any packages, unnecessary dependencies also will be installed along with this Python 3.9 if there is any unnecessary dependencies. Once you install a Python, I'm going to delete. Okay, I'm going to clean up here. See, after installing packages with apt-get, lot of metadata files are stored in var lib apt list. So these files are no longer needed after installation is complete. That's what I'm removing here. The reason, it will consume some space. That's what I'm removing here by using unnecessary files. Otherwise, you no need to run. Just if you want to, give some space allocation for other images, we can save our space to running this. So here first instruction is what? Taking OS. Next instruction is what? Installing Python and pip. And next instruction is what? Work directory app. See, work directory app means system can understand first app directory will be there or not in your local. If app directory is not there, it will be created automatically app directory and set to app directory. Set means what? CD. Next, copy dot app. Copy dot only means what? Current directory, all files we can move to, copy to app directory. Now, your cursor will be there inside app directory only. So inside app directory, you are installing pip install -r requirement.txt. So inside app directory, you have a Python code, you have a install requirement.txt. Okay. And next is what? Set a default command to run Python. So the executable commands, Python run, Java run, .NET run, these commands we need to be give CMD or entry point or both. So these commands, whenever give any instruction in CMD or entry point, these instructions only run while run the container from the image only. So if you can see here, till pip install only 5 by 5 commands only executed here, but my docker file inside also cmd entry point is there, but this cmd entry point is not executed while build the docker image. Cmd entry point executed when you run the container only. Run the container means, run the image means container will be created. Whenever container will be creating, at the time inside this CMD entry point will be executed. The meaning is what? You are running a Python code. So container will run a Python code with help of all. So whenever container will run a Python code, inside your app.py is there, requirement.txt is there. So if you run Python 3 app.py, it is able to run. Container is able to run. Okay. So here simple logic I can say in the later, what is entry point and CMD. So here you can give like this also. So no need to give entry point. Like this also you can give. But the meaning of this is, see here, Python is a fixed one. It will not change. Maybe the file will be changed later. So while runtime, while executing time, if you want to change your file name, CMD will support to change a file name. Local overrideable. We can give a, while runtime, Docker runtime, this file name we can change it if you write a different code. But entry point, whatever command you have given here, this is not overrideable while running a container. So in this case, entry point, whatever command you are going to execute, that is fixed one. So always Python 3 is a fixed one, right? It will not change in the future. Maybe app.py can change. If you develop a one more code, the name of app1.py. So here we can give a app1.py. Not here, not in the Docker file. While already Docker file is created, after that, while running a image time, we can overrideable. Even anyway, this is very difficult to understand this time. We'll explain later. So you just understand whatever entry point CMD commands are there. These are locally, these are executable while run the image only. Build image process only executable till here only, not CMD and entry point. The reason inside no processor will run in the image. Whenever you run image, container will be created like a server. It will execute the Python 3 app.py. So application will start at this time. Okay. Okay, let's understand now. So my image is ready, right? How to build, how to run this image. So Docker run command -dt detached terminal -p. So Python Flask application, it will run on 5000 5000 port number by default. So local executable port number you can give anything, no problem. But this is fixed one you have to give. Where exactly Flask application run on container port number 5000. So give the image name Python. So whenever you run a image, container will be created. Inside container, the CMD entry point already executed so that you are able to access your Python application. So let's understand now. Docker PS. See, here command is what? Whatever command you have given inside entry point and CMD, those commands will be executed inside. So that your container is created by running this command. Whenever you run this command, Python application will be executed inside the container. So that you can access public IP, your local host port number 5007. So first you should open you should whitelist 5007 port number inside your security group for your EC2 instance. See, Flask inside Docker is running fine. So clear till here? Any questions?
Veera,
Yes.
yeah, can you please explain like briefly?
Yeah, I will explain.
Okay.
Yeah. So let's understand now one more way of understanding. This is your EC2 instance. So your EC2 instance having hardware, operating system. So that if you want to deploy any Python application, so you can directly deploy Python application inside. That's what we discussed yesterday, how to deploy Python application inside your EC2 server. So simply what you need to do, inside your OS operating on top of your operating system, you need to install Python environment, install Python. So Python is installed. After that, plus dependencies you need to install on your OS, so that your server will execute your Python app.py application. If you run Python 3 app.py, so it will run the reason on top of operating system Python install dependencies install, so that it will be executed. You can give EC2 public IP following by 5000 port number. User can able to access your Python application. This is EC2 process. So the same process, how to containerize the Python application. Containerize is nothing but this is virtualize. So this is VM is EC2 is nothing but VM only. So this is virtualization concept only. We are creating VM means creating one EC2 instance. The background cloud is following cloud virtualization. But in this case, if I want to deploy 6 application, I need to create 6 EC2 instances. So it is very, costing and all. We need to consider costing and all. It is going to be the architecture is going to be, the big, also the maintenance and everything is also very difficult. For example, 6 application, if I want to deploy now, so this is application number 1 running in one EC2 instance. Same thing, I need to create one more EC2 instance. Install one more application. Same one more EC2. Install one more application. Same one more EC2. Install one more application. Each application running on one EC2 machine. So in this case, anyway, again, if if your application run on one EC2 instance, if the crowd, public are accessing, getting more requests, again you need to create one more EC2 instance. One EC2 is not at all sufficient to give a high availability concept. Again, you need to create a same Python 3 app.py in our AWS concept, AWS auto scaling concept. Again, I need to create one more EC2 server. So in this case, my instance count keep on increasing whenever load will be increased. Okay. So in this case, you need to deploy multiple instances, but without creating multiple instances, is there any process to minimize this architecture, to minimize the costing? Yes, we have a Dockerization. So Dockerization is nothing but what? Instead of installing Python dependency directly on your OS, so here what we can do, take a one EC2 instance, same hardware is there, operating system is there. Here, don't deploy your Python directly EC2 mission operating system. You can install Docker first. So Docker will provide isolation environment for each application. Okay, that's what I'm creating Docker. See here, Docker creating isolation environment for your all applications. So this is operating system. This is now hardware. So this is also hardware. Okay, let's understand now. So my Python application, I need to deploy inside your EC2 instance. But here, I'm not going to deploy directly inside of EC2 instance. I'm going to deploy on top of the Docker. So containerization is nothing but we are going to build a image from your source code application. So the image is nothing but artifact. From that image, we are going to create a container. To run an application, we need a container, we need a server, right? Here container is nothing but isolation server. Just understand here. Docker will create a 10 containers is nothing but Docker will create a 10 servers. Server inside servers. Like that we need to understand. Okay. So how to process this operation? So now you need to install Python here, dependencies here, and simply you can copy the code into your EC2 instance, run a Python app.py. So first instruction is what? Install Python. Next instruction is number 1, this is number 2, this is, and number 3 is what? Copy the code from the GitHub. Then so here run the code, 4 instructions. So same here, instead of doing this all activities directly into EC2 instance, we are creating a environments. Docker will provide a environments. For example, now inside my EC2 instance, already repository is there. Whenever you clone the repository by using Google, by using Git, your end repository will be there inside your EC2 instance, right? So inside your EC2 instance, this repository is cloned now. So what you need to do, from this repository, I'm going to create a one environment. So how to create environment? First, my end code is there. Okay. First, what I need to do, so I'm not going to depend on this OS. Okay. Same like a virtualization, but sharing the hardware to your containers. Okay. Hardware, whatever the Docker containers, to run a Docker containers, we need a hardware, right? Hardware will share from EC to EC to hardware, but not OS. The reason, this is already you created a one, you have taken one OS like Ubuntu or Amazon Linux. So if you create a Docker, also you should create same OS. Otherwise, these commands will not be executable. That's what Docker is. Independent OS for host machine. If the Docker is running on your host machine, Docker will not share operating system from the host machine. It will share hardware only. So in this case, okay, my application is there now. In this case, to run my application, I need operating system, right? I need operating system. The reason I'm not sharing operating system from the EC2 instance, only sharing hardware. See, if you can see this process now, to execute a Python code, if it is a virtualization concept, I need server. The server will provide operating system and hardware. That's what I'm choosing, a one server. Same process, I'm choosing containerization. So containerization process, I'm choosing only OS. What about hardware? Hardware will share from EC2 instance, host machine. So here, this point which is equal to this point now. So this point which is equal to this point, this is virtualization, creating one EC2 instance for one Python application. But here, creating inside environment, inside the server, you are creating a Docker environment. Rest all steps are common. If you can see, rest all steps are common. Okay, let's understand now again. Okay, see, my inside EC2 instance, instead of directly installing my Python code and dependencies and run, I'm creating a one environment. Docker will create environments. For example, now I'm creating inside server one environment. This environment is what? This environment is for Python application. Okay, in your end, Python code is there. Okay, to run this Python code, I need operating system. So which operating system? You can take anything. I'm taking Ubuntu. What about hardware? Hardware is share from, hardware will share from host machine to run this. Okay. Next, to run this application, so on top of this OS, need Python. Okay. So now OS plus Python is ready. So now Python is there, OS is there, but dependencies also required, right? The dependencies is related to your source code only. In this case, next what we need to do, taking the code from here. That's what we are using, copy instruction. Copy dot means from the current directory. Environment also creating in the current directory. Okay, copy dot means whenever you can run this command instruction, this entire source code will move to copy to this environment. Next, source code is there means inside source code dependencies also there, right? I'm running the dependencies. pip3 install requirement.txt. So now source code is ready. Source code is ready and dependencies is ready. Operating system is ready. Python is ready. So we need to start the code. We need to start the application. How to start the application? Python 3 app.py. So inside, whenever you copy the code, app.py will come, right? So we are running Python 3 app.py. So this command executing not for build process. This command will executing run process, Docker run process. So whenever you run Docker run, this CMD entry point instructions will be run executed now. So this is now container will be created like this process. This is one container now. So now when the container will be created, whenever you run only until and that, okay, let me show you. So until and that, even though CMD instruction you have given here, Python 3 app.py. So even though if you run Docker build command, so one image will be created. This image is artifact. Artifact is nothing but what? This image is not running anywhere. Image is just source code plus dependencies plus your Python plus executable command. Whenever you run this image, now this environment will convert like a server environment. Server environment is nothing but container in the Docker terminology. So whenever you create a container from the Docker image, inside whatever command cmd command is there, it will be executed inside. Whenever executed, this Python application will run inside the container. So you can give the container access to public. So this is the process now. So this is the environment. Docker will provide this environment. So whenever you build a image, if you build a image is nothing but just creating a one artifact ready to deploy only. When we can deploy, when we can run a image. Clear now? So this container hardware to run this application, it is sharing from host hardware. What about OS? OS is a independent. OS is not depends on your EC2 machine. That's what I'm taking Ubuntu OS. Are you taking any Linux OS? Clear now? Still any questions?
Yes, Veera, it's clear.
What about others?
Clear, Veera.
Okay. Okay. So now your application is running in the Docker container, not in your EC2 OS. Like that, we can create a number of containers, number of environments. The limit is depends on your host hardware, same like a virtualization. Your host hardware will provide, for example, this one container is creating like that number 2, number 3, number 4. This container is taking a 1 GB. So this is 10 GB means you can create 10 containers. 11th container space will not be there in your EC2 hardware. You need to increase the instance type and instance hard disk to provide a process again for 11th, 12th container. But operating system will not depend. That's what I'm taking a operating system from the Docker Hub. Okay. Okay. Now I will show you one thing here. Okay, I'm able to access my application anyway. Let's go inside. I'm able to access application inside anyway. Let me execute the container now. I mean, sorry, log in the container. Already running container. How to log in? Docker exec -it. So you can give the container ID or container name also you can give. So interaction means bin bash. So now directly app is there. Why? If you go for my Docker file, see, I'm creating a work directory app. Work directory app is nothing but if the app directory already there, it will be used. It will be used. Otherwise, it will be created automatically. Okay. After create work directory app means cd app. This is meaning cd app. You are in the app directory now. Okay. Okay. In this app directory, copy my entire code into the app directory. So the meaning is you need to understand here. Okay, let me exit from here. So here the meaning is mkdir app will be created. ls. So copy current app means what? All files you can move into app directory. But app directory will not create inside of your EC2 instance. It will be created your Python environment. Just for example, I'm showing you here. And work directory is nothing but what? CD app. Now copy all files into app directory. This is the meaning. But not here directly. It is creating an inside environment, inside container. When the container will be created, whenever you just created all instructions, whenever you can execute the container only, those will be executed. Until and that it will be converted into image format. The steps will be converted into image format. Whenever you run image, all steps will be performed. Create a container. See here. Now Docker image is there. Now Docker PS. So my container is running. If I delete my container, Docker RM, let's take the container ID here. Copy, paste, -F. Otherwise, stop the container and without -F, you can remove. So now if you can see no container is there in my end. I mean, your application is not running. You can access now, refresh now. See, this is virtual environment servers are creating. Server is nothing but container only. See now, container is deleted. Indirectly server is deleted, virtual server is deleted, inside application also not running. But again, but image is there, image is ready. Okay, simple logic, guys. So we are just, if you can go any stores. So we are doing the transactions by scanning the image. So in the initial days, we need to enter the phone number and amount and detail something. Now, no need to do that. Just scan. Whenever you scan that image, the background already steps configured so that we can directly make the payment. Same thing here. We are make it ready my application in the form of image. When we create an image by the help of Docker file, my image is ready means ready to create a container. If image is not there, how to create a container? Again, we are just we are writing some steps here, configurations here. I mean instructions here. First I need this. First I need this. First I need this, like that, and create a container. That's what we are doing. Same thing. Collecting the instructions, creating a image. Docker will run image only. Docker will not run file. That's what we are ready. We are building a image to ready to deploy. Now my container is not there, but all instructions are configured in the form of image. Whenever run a image, one virtual container will be created on top of your EC2 instance. But application runs on container, but application not runs on directly on EC2 OS. This is very important understanding. Let me run again. Docker run -dt. So I'm giving in -p 80. Sorry, you can give any port number 5065, whatever you can give. The default one is 5000 for Flask application, and give your Python image. Again, see all instructions executed quickly. See, you need to understand why. See why the CMD entry point are not executing while building the Docker image. See, Docker image is a backup for all the steps. If execute CMD entry point, what is the meaning? Image will not access from anyone, right? Image is an artifact. That's what CMD entry point not execute. What is the meaning of CMD entry point instructions in that? Execute your Python application. But inside image, we are not executing any Python application, right? That's what, except the CMD entry point instructions, everything will be work inside your Docker image. But when the CMD entry point will be executed, whenever you run Docker container only. So now I run Docker container means indirectly what? I run Python application. Okay, let's Docker PS now. Docker exec -it. So -it, give the container ID. This understanding is very important, guys. It's not easy to quickly understand. It will take some time to doing some practice. Yeah, I'm inside of container now. This app directory it is creating in the Dockerfile instruction only. Whenever you run, all instructions will be executed. So this app directory will be inside only, your application will be there, right? That's what you are in the app directory now. So if I give ls, see, all files are there inside the container. I have used the copy instruction to copy the file inside the app directory. That's what. For example, cd dot dot. You are directly inside the container home directory, not in app directory. If I give ls, see, inside no Docker file, no your application and all. So instead of directly creating your Docker file, your app.py requirement.txt, I'm just creating one directory. Inside directory only copying everything. Okay. Again, go to the directory what I have created, app. Now you can give ls. See, all files are there. Clear, guys? Any confusions here?
It's clear, Veera.
Okay, so you will get better clarity. I'm going to do some modifications now. Exit. Okay. Docker ps. So now I'm going to delete the container. Docker rm. Give the container ID here. So I'm giving just -f, forcefully remove. Okay. So now Docker ps. Okay. See here now. Now go to your images. Okay, now I'm going to do some modification into my Docker file, guys. Okay, so till here, my Python requirements, my Python installations, pip installation, everything will be clear, will be executed. Now what I'm going to do, I'm going to comment these 2 lines. Okay, I'm going to comment these 2 lines means my container will not execute any Python 3 app.py. Let's see what will happen now. Now, whenever modifications will come into the Docker file, again you need to build. So meanwhile, let me deal. Okay, let me execute, no problem. Docker build -t. Now I'm giving Python 2 version 2 version 2. Python already executed, right? Python image. Now Python 2 image. Tag name is, you can give any name. Dot means my Docker file is there in the same path. See, my image is ready. Till pip install only it will be executed, even though if you comment or uncomment the cmd entry point will be executed while run the container only. Now if you can see, I'm going to run the container, Docker images. Okay, let me run Docker run -dt -p. You can give any port number. This is default port number. Now you can give Python 2. See, container is created, but if I give Docker ps, again you can give Docker ps. Okay, see, let's go to now access 5671. See, my application is not running. The reason Python 3 app.py is not executed. If Python 3 app.py is not executed, how application will run? How to run a Python application? By running Python 3 space app.py. Okay, let me execute this container. Let me log in this container. Docker exec -it, give a container ID. See, you are inside of the container, right? ls. See, but I ran copy instruction, right? That's what all files came here. and I ran requirement.txt, right? So all dependencies are executed. Now I will execute manually Python 3 app.py. See, now it is running. Now it is running. But this step you need to configure in CMD entry point instructions. No one can log in the container or run this application is not at all recommended way. So that's what this command I'm going to run through CMD. Whenever container will be run, I'm going to access directly. This is a process we are going to follow actually. Exit. Exit. ls. So let's go to vi docker file. So if I give CMD entry point, it will be executed whenever container will be created. That's what. Clear now? Clear or any questions? Okay. Now let's understand now. vi requirement.txt. So inside Flask application is there, right? I'm going to delete now. Save the file. ls. Now again, Docker images. So if you use the existing Docker images, inside Docker images, requirement.txt inside Flask already there. Again, you need to rebuild the image. In that image only Flask will be missed. Okay, meanwhile, let me delete all images. The space is consuming here. Since it is a T2 micro only, Docker rm I images, give Python to Python -f. Docker ps Docker rm container id, copy, paste -f. Container also deleted. Now Docker images. Nothing is there my end. Okay. Let's build now. So the changes are what? I made only one change. Inside my requirement.txt, I have deleted Flask module. Sorry, I have deleted Flask module. So dependencies are missing now. Okay. Let's execute this image now. Docker build -t tag Python 3 dot. So build will not fail, guys. So if the empty instructions means pip will install, requirement.txt will be executed, but inside nothing is there. But Docker will not throw any error. Nothing is there means okay, no dependencies. That's what image is configure now. My image, one of the instruction is what? Without dependencies, your Python code will not run. So here my and requirement.txt wantedly I removed my Flask dependency. Now image is prepared with missing dependency. Let's run the container again. Docker run -dt -p, give again 5789 something any port number 5000. My image name is what? Python 3. Sorry. Oh, again mistake. Docker ps. Docker ps is not showing any container. Understand here. Let's give Docker ps -a. Okay. See, now my container is exited state. Understand very carefully, guys, here. whenever I can give Python 3 app.py in the CMD instruction, I'm saying to my container, execute this application by running this Python 3 app.py. Yes, my container is trying to execute this, but definitely inside my Python end got some error, missing dependencies. That's what container is went into the exit state. Container exit state means what? Application is not running. How application will run without dependencies? That is the meaning. So out we can check the logs also. Docker logs, give the container ID logs. To check the logs of this container ID. Okay, see these logs. File app.py line 1 in module from Flask import Flask. So when code will be executed from Flask import Flask, it is trying to import the Flask from requirement.txt, but inside the requirement.txt nothing is there. No module named mean. No module named means Flask missing. Without Flask, this Flask application will not be executed. That's what container started the code and exited into same state. That's what container is in stopped state. Even Docker ps-a. Let's execute. Let me log in this container exec -it. Take the container ID. Bin bash. See, it is not possible. Stopped container we cannot log in. Whenever container is running only we can log in. That's what I'm checking. What is the issue here? By checking the logs. So my logs are saying that your container is stopped due to missing the Flask. That's what container is not running. Okay. Okay. So here we can do one thing, guys. Here we can do one thing. Let's go to, we can run this container, even at least Python application. I mean, we can run this container. We can just move it into the running state by changing the Python 3 app.py. So if you give Python 3 app.py means we are saying you should execute this command only. That's what container may get an error. So what we can do here, we understand the concept here. So we just hard code this one. Sorry, we can comment this one. Whenever you can comment this one, this 2 will not be executed. At least container will be run like a empty container. Only Python will be installed only. So otherwise, what we can do, simply we can give here version. So what is the meaning? I'm executing the command inside Python 3 version only. So definitely container will be executed this command. So container will be in the running state only. The reason I'm not executing application, if you say, hey container, you can create and execute this application means what? Sorry, missing dependencies. That's what I'm going to enter into the exit state. Hey container, you can run and execute only Python 3 version means what? Yes, Python already installed my end. That's what it is not going to the exit state. It will be executed Python 3 version only and keep on running your container. This is the process. Clear? Any questions?
Clear.
Okay, let me run this one. My version is what? Python 3.9, right? Let me give here Python 3.9. Let me run this container. Before that, we need to build image again. Docker build -t. Docker build -t. Python 4 now. Give dot. Okay. Now Docker images. Now you can run Docker. Sorry. Okay, given Python, not Python 4. Okay, Python only given. Okay. Now execute this content image Docker run -dt. Guys, we should not give -p now. This is Flask application, but inside Flask application is not there. Either you can give no problem. No problem. But it will not be executed. That's it only. Python. So container is running now, but it will not access, it will not be accessible. The reason you are not running application inside the CMD entry point. So container will not execute your application. So meanwhile, you can check Docker PS. Okay, again, my Docker PS also not running. Okay, let's understand my command may be wrong. CMD entry point command may be wrong. Docker logs. Okay, let me check PS-A to check the container ID. Okay, so Python 3.9 version is wrong actually. So Python 3 version is there. Python 3.9 version is not there. That's what wanted I run this command. Anyway, check the logs. Docker logs. Give a container ID. See, can't open this file. See, Docker logs. If you run the Docker logs means it will give a state of your executable command inside the container only. So it will run version. So error 2, no such file or directory. That's what my command is wrong. So what I can do? Inside only Python 3 version only, not Python 3.9 version. Let me ask to ChatGPT. Modify this inside container. Check version. So Python 3 version is the correct, not Python 3.9. Okay, anyway, see Python 3 version is correct, but I ran what Python 3.9. So let's start the process again so that we can vi Docker file. So let me change one more time. I will try. Python 3 only, right? WQ. Again, Docker build -t tag. So let's give Python 4 dot. Okay, let's execute Docker run -dt -p. It will not executable even if you can give this port forwarding since application is not running here. So Python 4. So Docker PS. Still it is not running. Why? Docker PS -a. Python 3 version is correct only, right? Okay. Let's queue only Python. Again, Docker build. Just I'm running only version command only inside the container. Let's run again. Container. Just give Python 5. Give here any number. So Python is not running. The reason I'm installing Python 3.9 only. That's what Python is not executable. Directly container is not created. But Python 3 should work. Okay, let me take this Docker file. Copy. I'm unable to get Python version. Oh, sorry. We have to give 2 spaces. Yes. Anyway. It's my bad. Command is Python 3 space hyphen version, right? Not Python 3 version. That's what. Okay. Docker images. Command is wrong. Okay. Docker PS. Okay. I'm going to remove all images. Docker system prune hyphen A means all images. Yes. Docker images. Okay. Nothing is there. Let me execute now. Docker build hyphen T. Python just give like this, all images deleted, right? So each instruction will work like a one layer inside the Docker environment. Okay. Now Docker images. Okay. Let's Docker run hyphen DT. So hyphen P. So we are not supposed to run hyphen P. The reason the application is not running inside the CMD entry point, it will not run app Python 3 app.py, right? Anyway, 569, give any number, 5000, give Python. Okay. Docker PS. Still it is not running. Why? Docker PS hyphen A. Docker logs. Why it is not running? Copy. Paste. Yeah. It is printing 3.8.10, right? Okay. Got it. Docker run hyphen DT Python. Let me check. This is everything is correct only. Okay, okay. Okay, got it, guys. This is correct behavior only. So the reason already container print the, see, this is not continue process, right? Printing version is not a continuous process, but application, executing application will be continuous process. Application keep on running. That's what container is also keep on running. But this is the meaning of the Python 3 version is what? Container just print the version and it will be going to exit state. That's what the problem we are facing here. This is correct only. Okay. So let's give here again Python 3 app.py. So Docker build Python 9. So Docker PS, sorry, Docker images Python 9 out. Docker run -dt. Oh, Flask also missing, right? So that's what we are configuring through Jenkins pipeline. No need to run every time. If any modifications will come, immediately pipeline will be triggered. Everything taken care by pipeline only. Here every time manually Docker build is a headache process. Requirement.txt. Let me add Flask here. Flask. Okay. Let's run again. Docker build, give Python 10. Same name if you can give, it will not take. That's what I'm giving. Different. So Docker run -dt, give 511 any port number. Sorry, give -p, give 5000, give Python 10. Now give Docker ps. Okay, so this is executable process, right? It will not execute, it is keep on running. That's what container is running. If your application will be stopped, immediately container also will be stopped. So we have given only just print a version. Print version is a just single process. Just give a print and it will be execute. So container, and inside the container any process should run until that container only into the running state. Otherwise your container will be go into the exit state if any process are not running. So let's go now Docker. So you can access, even it will be accessible. Copy, paste, give 5111. So I'm going to access application. So let's log in, exec-it, give the container ID, copy, paste here, and bin bash. So you are inside of the container. See ps -ef, if I give one processor is running Python 3 app.py, so that your container also run. But if you print any version, this processor will not run. If you give ps -ef, immediately container will go into the stopped state. So when the container will run, any process will run. The process depends on cmd entry point command. So until run the process, only container will run. Otherwise container will go into the stopped state. Clear everyone now? The process and all. Any questions?
Image pull.
Sorry, I miss your voice. I'm audible now.
It's clear, Veera.
Any questions from anyone? So please practice Docker file. No questions from others?
Clear.
No, Veera. Clear, Veera.
Okay. See, I will show you one more thing here. Instead of taking Ubuntu image, directly you can take Python image also. Understand here? See, directly taking Python image, set copy.app work directory, install your required dependencies and run your Python application. But I'm taking Ubuntu and by using run instruction, I'm installing Python and making my own image. Or you can take directly Python image from the Docker Hub registry and give your copy your code, copy your dependencies and install your dependencies, run your Python Docker file. Understand the difference here? Understand the difference?
Yes, Veera.
Yeah. So this is only printing CMD Python 3.9. So it will not run any processor. May it will be executed if you run this Docker file. So this will print also Python version. So this will print Python app.py application. This is also Python 3 app.py. The difference between this Docker file and this Docker file is here I'm taking directly Python image. Here I'm taking Ubuntu and I'm making my own image from the scratch. This one already someone pushed this image into Docker Hub, Docker providers. I'm using directly Python image. So definitely this Python 3.6 background, one Docker file will be executed by Docker providers. After that, they can build an image. After that, they can push that image into Docker Hub registry. We are using that image only. Clear? The understanding here? So that I will
Yes,
share
we
this
are.
file to everyone. Yeah. Okay, just practice Python deployment process. First, do the process, manual process. Then please try with Docker file instructions. And Monday class, we will discuss how to deploy Python application, Node.js application, and how to deploy Python file for Java application. So only we have to focus. Docker file is very important concept where we can change the deployment strategies in the Docker file only. Remaining all are same. Even Python application, Java application, Node.js, whatever it is, the difference will come inside only Docker file. Remaining process, everything is same. And even Python, even Docker file, you and developer sit together and write a Docker file. It's not like alone you can complete. You don't know exactly what kind of dependencies required, where exactly we need to move the file, which directory they are using, everything they can give. So with help of the instructions, Docker instructions, we can prepare a Docker file. That's it only. Clear?
Yes, Veera.
Okay, so thank you so much guys for today. The next class will be on Monday. So meanwhile, I will share this Python Docker file document, just 4 Docker files, execute one by one and try to understand. Thank you so much. Bye-bye.
Thank you,
Thank
Veera.
you.
Thank you, Veera.
Yeah.